We're going to look at a few triangle constructions, and then we'll look at some other constructions that have to do with squares. So let's start with two triangle constructions. We'll construct an isosceles triangle and we will construct an equilateral triangle. So let's start with an isosceles triangle. An isosceles triangle has two congruent sides. So let's suppose that this line segment is the side of my isosceles triangle that is not congruent to the other two. So I just need to make a decision about how long the other two sides are going to be. So I'll say that they're about this long. So from this end point of this line segment, I can make an arc, and from the other end point, I'll make an arc with that same radius. And where those two arcs intersect gives me a point that is the same distance from the two end points of the original line segment, which means I've got a triangle that has two congruent sides, making it isosceles. So this side and this side are congruent. Now to make an equilateral triangle, I'm going to start with a line segment again, and this time I'm going to make sure that my three sides of the triangle are all congruent to this line segment. So I need to measure it. So there's how long this line segment is. Now I want the other sides to be that same length. So from one end point of the line segment, I'll make an arc, and from the other end point, I'll make an arc. And because I measured the length of that line segment, and I use that same measurement to define the arcs, that means that all of these line segments that I get are going to be congruent. And if all three line segments are congruent in this triangle, then I must have an equilateral triangle. Now, since we're going to be doing some constructions based on squares, let's see how we can construct a square. We know that a square has four right angles. So the first thing we're going to do is simply construct a right angle, and that's something that we've done before. So let's start with a line segment. I'm going to put a point on that line segment, and I want to construct a perpendicular to that line segment through the point. So I'll put the point of the compass on the point and make arcs on either side without changing the setting on the compass. And then I will stretch the compass out a little farther and put the point of the compass on each of those intersections I just made and make two more arcs that intersect. Now that intersection and the point we started with will give me 2 points to connect that will also give me a perpendicular to this original line segment. Now that's a right angle that I'm going to use as one corner of my square. Now I just need to decide how long I want the sides of the square to be. So I'll just make a decision that they're about that long. And I'll put the point of the compass at that first vertex of my square and make an arc through this line segment and this line segment. So these two intersections are defining two more vertices of my square. There's one more vertex out here somewhere, and it is the same distance from these two vertices I just found. So I have not changed the setting on my compass. I'll make an arc from that upper vertex, and I'll make an arc from this right vertex. And where those two arcs intersect is the fourth vertex of my square. So all I have to do now is connect the vertices of my square that one, and these two. And because we started by constructing a right angle, and we did not change the setting on the compass when we constructed these other line segments, we know that what we've got is a square that has 4 right angles and 4 congruent sides. Our next construction is the sacred cut. Now, to give you a little bit of background, the sacred cut is considered sacred because it uses both circles and squares. And circles and squares had special meanings. In Da Vinci's Vitruvian Man, you can see that Da Vinci tried to relate both the circle and the square to the proportions of the human body. The circle was considered the divine part of the human body, the cosmic part, and the square was the earthly secular part. So it was Da Vinci's way of saying that man is both divine and secular at the same time. The sacred cut involves circles and squares as well. And if you look on the right, what you'll see is 4 intersecting circles and a square inside of that. Our construction is going to involve just this square, although you'll notice inside the square you see an octagon, which can also be drawn. And that octagon is something that you see with religious references, because the octagon is a shape that you'll often see used for baptistries and for baptismal fonts. So we're just going to construct what you see inside that red square, but we will not be finishing the octagon part of that construction. So I'm starting with a square already. We could have constructed this square. Instead, I'm just starting with something that is a square, although it may look a little distorted because the camera seems to be distorting this a little bit. You're just going to have to trust me that it is a square. So the first thing I want to do is find the center of this square. I want to find where the diagonals of this square would intersect. Now I could draw both diagonals in, but I'm going to, rather than cluttering up my construction so that you can see everything that's going on, I'm going to simply use my straight edge to connect this vertex and this vertex. So I am connecting 2 points, and I'll draw a line segment there. And then I'll do the same thing over here and draw a line segment there. So where those 2 line segments intersect is the center of the square. So it's where the 2 diagonals do intersect. Now the next thing I want to do is find the distance from any of these vertices to that point of intersection. Now it's going to be the same distance all the way around, because these diagonals intersect at a point that is the same distance from all of the vertices. So the next thing I want to do is put the point of my compass on the vertex of the square, and I want to draw arcs that intersect the sides of the square. So there's one. Here's the second one. Oops, I think my compass slipped a little bit. There we go, that's better. Here is the third one. And notice how those are all intersecting right at this center point. And the fourth one. Gotta get the other half of it over here. All right. So this is what's called the sacred cut. And you could draw that octagon in that you saw in the other picture if we connected up these intersections. For example, this one and this one, connect those up with a line segment. Do that all the way around and you would have that octagon. So our last construction is of something that we've already talked about, the ad quadratum figure. Now, we've already talked about this figure. It consists of a square that is inside another square. And what's important is that the midpoints of the sides of the larger square are the vertices of the smaller square. And we also said that you could continue to nest these squares as many times as you wanted to. But what we're going to be looking at is not all of these nested squares. We're just going to construct this figure. Now, just like with the last construction, we could have constructed a square, and I guess a purist would want us to do that construction, but we're going to start with a square. So if this doesn't look exactly square, once again, it's because the camera is distorting things a little bit. But we have a square, 4 congruent sides, 4 right angles. So we want to nest another square inside of that, and what's important is that the vertices of the inside square have to touch the midpoints of the sides of this larger square. So I need to find the midpoint of one side at least. So what I'm going to do is just look at this line segment right here and try to find the midpoint of that line segment. So basically I'm going to think about bisecting that line segment. Now I could take that line segment, copy it off to the side, and do the construction off to the side. In this case I'm just going to do it right on this picture. So I'm going to make the compass a little more than half the distance, and I'll make an arc on either side of this line segment, and then without changing the compass I'll go down to this other endpoint and make arcs that intersect those. So now I could connect those up with a line segment, and that line segment would be perpendicular to this side of the square. But what I'm really interested in is this midpoint. So instead of, once again, cluttering up the whole picture so that you can't really see what's going on, I'm just going to do this. I'm still connecting up these two intersections, but this point right here is the midpoint of this line segment. So I've got a distance I can use. I can say that this distance from here to here is half the distance, half the length of this line segment. So I can copy that distance to all the other line segments by going from the vertices, which remember are points, and making arcs on these sides. And so now what I've got is 3 more intersections, which are defining 3 more points, and the 4 points that I've drawn are the midpoints of the sides of the large square. So if I connect those up, I will have an inner square that has vertices that are at the midpoints of the outer square, which will make this an ad quadratum figure. Now I could continue this if I wanted to. I could find the midpoints of the smaller square and use those as vertices for an inside square, but I'm just going to do the one square. So now that we've constructed this figure, let's look at a few other things about it. First of all, you do find this figure in art and in architecture, and this is one rather striking example. This is in Pisa, and this Duomo is right next to the Leaning Tower of Pisa. If you look above the doors on either side of that center door, well, actually kind of above and between all those doors, you will see that ad quadratum figure. It's a rectangle, or excuse me, a square drawn inside other squares. There's also some math involved in this figure, and we've really already talked about this, but I'd like to review it a little bit. We've said that the area of each square is twice the area of the smaller square inside it. So if I would say that this square is maybe 1 unit by 1 unit, meaning its area is 1 square unit, That would mean that the square that is one size larger than it has to have twice the area, or 2 square units. And the area that is just bigger than that has twice the area of the previous square, or 4 square units. And the area of the next square is 8 square units. And if you look at those numbers, 1, 2, 4, 8, you'll probably notice that what we've got is a geometric sequence. It's a geometric sequence because we are multiplying by a common ratio to get from one number to the next, and that common ratio we're multiplying by is 2. And another thing that we've already looked at mathematically about this figure has to do with the side lengths. And we've noticed that there's a pattern in the side lengths, and the side lengths form something that's called a root 2 sequence. And a root 2 sequence is another geometric sequence, but in this case the common ratio is the square root of 2. So if we go back to that inner square, and let's say that we've decided that the side length of that inner square is 1 unit, then the side length of the next largest square has to be the square root of 2 times that 1 unit, or the square root of 2 units long. And the side length of the next square is the square root of 2 times the previous side length. So the square root of 2 times the square root of 2 is 2. And the side length of the next square is the square root of 2 times the previous side length, which is 2 times the square root of 2. So we've got another geometric sequence here, but in this case the common ratio, that multiplier to get from one term to the next, is the square root of 2, which is what makes it a root 2 sequence. So as with all constructions, you know that you only get better at them if you practice them and try to see if you can do the constructions without listening step by step to them being done. We'll get a chance to practice some of this in class as well.